Derek from Tomcat Gas Training, and welcome to this video on everything a trainee gas engineer needs to know about cookers. But before we get into this video, please could you take some time to subscribe because it helps, and don't forget to hit that notification bell because you want YouTube to tell you when we're uploading videos. So, done enough waffling now and messing around, so without further ado, let's get on with it. Now remember, you have to be gas safe registered to install a cooker, and also if you look on the back of the gas safe card from the engineer, it will tell you if they're qualified to fit cookers. That's the first thing. Let me just give you a quick tour around the cooker. Now let's start at the back here. This grill is not just decorative, this is where the products of combustion will come into the room. So a cooker is a Class A appliance. That means it's a flueless appliance. That means its products of combustion will come into the room where this is installed, hopefully the kitchen. So we might need ventilation in different sizes of room, but we'll have a look at that later. But you definitely require an openable window for this cooker, or some other direct access to outside like a patio door or a door. If you haven't got a window, that's the ventilation, and I'll talk more about ventilation later. Okay, so we know the top is the hob. So in here we've got 4 rings. Some of them do have some more, but most of them have got 4. And then we've got the knobs across the top. Now the knobs are incredibly important because you need to be able to turn the stuff on and off. But the other thing what's important is it needs to be labelled, and the labels need to be clear, because if they're not, we could get misuse of the cooker. So you might think you've turned the oven on and you've turned the grill on. So that's massively important that these are clearly marked. Also, the taps, the gas taps on the front, can't be broken or missing. If you're trying to use a cooker where the gas taps are broken or missing, why? It's dangerous. You could leave a gas leak. But the other major thing is, why are they broken? Why are they missing? Is it the seals have gone within the grill or the oven or the top oven? So that's majorly important as well. Also at the bottom here, it allows air in for combustion for the oven. So there's certain clearances we need to make sure we've got, so we don't stop air getting into combustion. And one of the things you never ever do, especially in caravans in the winter months, is block up the air vents. It's a massive no-no. You never block an air vent for a cooker because it's a flueless appliance. So if it needs that air for combustion and you go blocking it up, it's going to fight with you, the customer, to breathe, because it needs air for combustion like you need air to breathe. Okay? Other things is, if you've got signs of scorching around the cooker on combustible materials, why are you using the cooker? Why are you still using the cooker? It's dangerous. So help yourselves by making sure you don't continue to use the cooker when it's broken, things are missing, you can't read things, it's full of grease and fat, okay, and the safety devices don't work. So it's down to the customer, not engineers. When we go to look at other appliances under our IGN G11, we need to, if we encounter an appliance, we need to check them now. Well, we've always needed to check them, but don't get on the back of the engineer if an engineer comes out to service your boiler and finds your cooker dangerous. And never ever use your cooker as a space heater. So never use it to warm your house up or your caravan. Doesn't matter how desperate you are for warmth, huddle together. Yeah, we can still do that with each of our families, but yeah, don't use it to heat your house or your caravan, because you might never wake up. So please help yourselves by looking after your flueless gas appliance, because it can give off deadly carbon monoxide. Now, there are several warning signs that the cooker could be giving you to tell you that it actually is giving off this deadly carbon monoxide. So what I'm going to do now is I'm going to show you a few things about the cooker that you need to be keeping a mindful eye open for. Now, first thing, the flame on your cooker needs to be a nice blue flame, okay? If it looks like that, that's giving off deadly carbon monoxide. So, if you've got nice blue flames, that's good. If you've got yellow floppy or orange floppy flames, that means it's dangerous. So, you either need to get your cooker serviced by a gas safe registered engineer, or you need to clean the cooker. So, dangerous. Other telltale signs that your cooker is giving off carbon monoxide poisoning is, do you have any black stains on the wall or on the ceiling where the cooker is? That's a big indication, because if you've got incomplete combustion, you will get soot deposits coming from the gas. Okay? Also, the byproducts of burning natural gas normally is carbon dioxide and water vapour. If we get incomplete combustion, that's where we get the carbon monoxide from. So if you've got excessive build-up of condensation on your windows, that could also be a telltale sign you've got incomplete combustion. So there are other signs of the actual gas hob, what could be causing the problem of carbon monoxide poisoning. So while we're at the top of the hob as well, if you have a glass lid, there will be a safety device on there. Let me just turn the gas back on. So your gas engineer, when he's checking the cooker, when he's installing it or when he's servicing, will have to check the safety devices. But that doesn't mean you can't check your safety devices as well. Now, you need to be very, very careful when you do this, okay, and follow this to the letter, really. So, first thing we need to do is, the smallest ring on the front, I'm going to turn it on. Okay, so I've got my smallest ring on the front, okay. I'm now going to slowly drop my glass lid down. And that ring should go out, which it has done. And this cooker actually turns the knobs off as well. Other cookers don't. When you lift the lid back up again, then they can actually bring the gas back in. So now I've done that, I can actually light all my rings. But what I always do is the other three bigger rings, just turn them down to minimum, just in case it doesn't go out, and then you can slowly close the lid and it turns off. So you notice how it went up a little bit because these knobs turn off. So that stops any heat then shattering the glass. So just be very careful. You should do this to make sure your safety device is still working, and I can't stress anymore how careful you need to be when you're testing this. Now, if this glass is broken, then get it replaced. If this glass is missing because you've shattered it, then get it replaced. Now, if you try to override the safety devices for this cooker, it makes the cooker immediately dangerous in our unsafe situations procedure. So never ever override the safety devices of cookers, ever. Okay, because it could end up with death. So that's checking the glass lid if you have a glass lid. And again, my last warning on this, be incredibly careful when you're doing this, because you don't want to shatter that glass lid. Now, before we get cracking, let's just talk about the locations where you can and where you can't install a hob or a cooker. Now, the first thing is, you can't install a cooker or a hob in a bathroom or a shower room. They're flueless appliances. Also, if it's a bed sit, the bed sit has to be greater than 20 meters cubed, the volume of the room. Okay, you can have a single ring or hot plate, but we'll talk about ventilation for cookers later on in this video. Next thing is combustible material. How far away from combustible material? So if we look at the hob first, we kind of need we need 50 mil at the back here if it's going to combustible material, and also from the side of the actual hob we also need 50 mil coming up. Okay, now if we've got cupboards on the side, the cupboards need to be 50 mil away from the edge of here, and as long as they're 460 mil up, that's okay. And then we've got 760 from the top of here to the bottom of any combustible cupboard. If you've got an extractor above your hob, then you need to consult the manufacturer's instructions for the actual hob itself. So 50 mil, 50 mil, 460 for cupboards this side, and 760 directly above. That's for the hob. Let's have a look at a freestanding cooker. Now, if we look at this freestanding high-level Grille cooker, the measurements are a bit different. So from units to the side here, we need at least 20 mil. Then from units at the side, we need 150 mil. And then anything above the grill, we need 610. So that's 20 from the side, 150 away from cupboards, and 610 cupboards need to be above it, or combustible material. So that's pretty much a standard, but obviously you would check the manufacturer's instructions to see what the manufacturer actually tells you the cooker or the hob requires. So that's your installation away from combustible material. So the first thing we need to do is make sure the room is greater than 10 meters cubed, which it actually is, and it's got an openable window, which it has, but this also has a back door, so really it only needs to be greater than 5 meters cubed. So the first thing we need to do when we go into the property is 1, the room big enough, and 2, does it have purge points? Now, this is the cooker we're replacing with this one. Now, before we touch anything, the first thing we need to do is go around with our non-contact voltage indicator and make sure that nothing's live. The appliance, the boiler, the gas meter. First of all, we need to test it. So that's working. We can now, that's plastic in front, so that's okay. Nothing live with the gas pipe. Retest it. That's fine. We can now go and do the meter. So let's go and do our visuals on the meter and let's get a tightness test on. So here's our gas meter. These awful smart meters. So it's got a bracket, it's got copper on the outside, we've got earth bonding, ECV is accessible. Let's just check and make sure nothing's live. Let's check that's working. That won't work if it's dead, if it's turned off. So that's working. So we're safe to do a tightness test. So let's get a tightness test on. So first of all, we need to open appliance isolation valves and extinguish any pilot lights if the appliance has got a pilot light. We then need to raise any glass folding down cooker lids because we need to test the shut-off valve for the lid. We need to connect a pressure gauge to the meter test point. We now need to level and zero this pressure gauge, and what we mean by that is we need to set our water level so it reads 0 on both sides of the legs of the U gauge. We now need to carry out the let-by test of the ECV, the emergency control valve, the AECV, or the alternative emergency control valve, or the MIV, or the meter inlet valve. We need to raise the pressure between 7 and 10 millibars and then close the test valve. We need to test for 1 minute. So if we get less than 0.25 rise on a U gauge, or 0.2 on an electronic gauge to 1 decimal point, or 0.25 for 2 decimal points, then we can say it's passed. So if it fails, we need to check the ball of the ECV valve under test. And we do this by spraying LDF, or leak detection fluid, on the ball. If the let-by is confirmed, we need to contact the ESP, or the emergency service provider. So that is the let-by test of this little thing. Let's look at temperature stabilization. Now, this temperature stabilization is exactly what it says on the tin. It's a 1 minute test to allow for differences in temperature of maybe the gas coming in and the temperature either outside or in the building. So, we need to rise the pressure to between 20 and 21 millibars for 1 minute. If it rises or falls, all we need to do is adjust back to between 20 and 21. So it doesn't matter if it rises or it doesn't matter if it falls, it's just a 1 minute test. But it does give you an indication of whether there's a leak or not if it starts to drop. So, temperature stabilization. And finally, the tightness test itself. So at this between 20 and 21 millibars, we test for a further 2 minutes. So if we've got no perceptible movement on the test, we can say it's passed. So what we mean is we haven't got this 0.2 or 0.25 rise or fall while we're doing the test. We can deem it's passed. So let's have a quick look and see what we're allowed before we actually say it has failed. Now, in some certain circumstances, we're allowed a pressure drop when we carry out a tightness test. And I want to make a few things clear here. Now, if we're testing a brand new installation with a gas meter and pipework and appliances, it's a 0 drop. There's no tolerance whatsoever. You cannot have a drop. But if we're testing an old installation with a gas meter connected, pipework and appliances with no smell of gas, we're allowed a drop. So the table behind me will show this. So remember, this is for a gas meter, pipework and appliances with no smell of gas. So if we've got a meter, a U6G4 with pipework equal to and less than 28 millimeters, we're allowed a 4 millibar drop. Remember, with appliances connected and no smell of gas. If we've got a U6G4 with pipework greater than 28 millimeters but less than and equal to 35 millimeters, we're allowed a 2.5 millibar drop. Again, appliances connected, no smell of gas. If we've got an E6 meter with pipework equal to and less than 28 millimeters, we're allowed an 8 millibar drop. Again, appliances connected, no smell of gas. E6 with pipe work greater than 28 but equal to or less than 35 millimeters, we're allowed a 4 millibar drop. If we've got a G10 U16 with pipe work equal to and less than 28 millimeters, we're allowed a 1 millibar drop. And if we've got a G10 U16 with pipe work greater than 28 millimeters but less than 35 millimeters, again, we're allowed a 1 millibar drop with appliances connected and no smell of gas. But if you're just testing the gas carcass, so that's gas meter and gas pipe, it's 0 drop, whether it's new or old. So if you've got a gas meter and pipe work, it's 0 drop. So if you go to a property, you do a tightness test, you've got a 3 millibar drop on your installation with no smell of gas and the customer hasn't reported a smell of gas, what you should do next is isolate the appliances and test to see whether it's on the meter or the carcass, the gas carcass. Because if it is, you're allowed a 0 drop. So this is where trainee engineers get confused and start putting comments down saying we're not allowed any drop. We are allowed a drop as long as it's old installation with appliances connected and a gas meter and no smell of gas. Now then, if you go to test a flat and it has a commercial gas meter feeding all the flats, you can't do that test, but there should be an AECV, or an alternative emergency control valve, within the flat with a test nipple where you can carry out a tightness test. And we do get a permissible drop in that. So remember, we've got no gas meter. We can't test from that. We've got pipe work and appliances with no smell of gas. If the pipe work is equal to and less than 28 millimeters, we're allowed an 8 millibar drop. If the pipe work is between 28 and 35, with no smell of gas and appliances connected, we're allowed a 4 millibar drop. But remember, no appliances connected, then it's 0 drop. Okay, so hopefully that makes it clear on when and where we're allowed permissible drops on a tightness test. So that's the first tightness test passed. Now let's go and get it out. First thing we need to do is get this out. Electric supply and the gas supply is in this cupboard here. So that's the power supply and the gas supply. So I'm going to have to move this cupboard and alter the pipe work. So looks like I'm going to have to take this cupboard out and alter the gas pipe. I can't do the electrics. That came off easy enough. So that's the cupboard out of the way. Gas pipe, what we're going to do now is we're going to look in the manufacturer's instructions and see where the manufacturer wants the gas pipe put in. Now not every cooker can allow the gas pipe to go in the same place. They're all different. Well, not all different, but most of them are different. So you've always got to check and make sure that the gas pipe's in the right place. So let's get on with putting the gas pipe in the right place. Now, when you're installing a cooker bayonet, the backplate elbows and the backplate sockets, it's always better to put that backplate in than that one, because that one sticks off the wall and stops the cooker going back, where that one sits flush and allows the cooker to go right back to the wall. So when you're installing a cooker, don't take that one, take that one with you. Now, the manufacturer's instructions for the cooker are always rubbish. It basically says when you're installing the bayonet to keep it away from the hot parts and the fluid part of it, and put it to the British standards. And at the moment the British standard says we need 750 from the floor to the centre there. So that's 750. And that's where we need to drill our holes. Now when you're making the bayonet into back plate, use this stuff. This stuff is gas tight pipe jointing compound. Better than PTFE. So you just spread it on the thread. Wipe the excess on the inside. Line it up. And then just get a bit of cloth and wipe off the excess. Okay, now what the regulations say is every cooker requires some kind of stability device, whether it's a bracket like this one or whether it's a chain like this one. So what the regulations basically say is if the cooker manufacturer has a slot in the back of the cooker, then you have to use a bracket, and the bracket has to be fixed to the wall and the floor, and that stops the cooker pulling forward and tilting. It also is there to protect the hose and the pipework being ripped away from the wall. Okay, so that's basically what the bracket's for. As a rule of thumb, cookers with a high level grill will require a bracket, but a lot of the low level cookers can get away with the chain if the manufacturer says so. Now first thing is the hook needs to hook into an eye which needs to be connected to the fabric of the building, not the gas pipe. You cannot connect to the gas pipe. Okay, now the other end, you follow the manufacturer's instructions. Now some of the manufacturer's instructions for the cookers, they say where the gas pipe comes down from the cooker, if there's a bracket at the bottom and it's secure, then they give you this to fit round the pipe here. But if it hasn't got this securing bracket and isn't the strongest part of the cooker, then they say connect it to the side of the cooker by using one of the screws in the side. And this chain is there not really to stop it tilting, it's there to stop you pulling the hose out. Some guys say it's these brackets are here if kids stand on the doors and stuff like that. They're not going to stop kids climbing up on top of cookers and tipping them over. Okay, they're there to try and prevent it. Okay, if you really want to pull a cooker over, you'll pull a cooker over, so you've got to be incredibly careful. And then the last thing is the hoses. You've got to make sure you've got the correct hose for the correct gas. So if it's an LPG cooker, this needs to be an LPG hose, not a natural gas one. Okay, and the hose cannot touch the floor, and there's a standard now from the floor to the centre of the bayonet of 750mm, but follow the manufacturer's instructions when you're installing the bayonet. And again, you can only install a cooker if you are gas safe registered. But what it does say in the regulations, the reason why this is a self-closing bayonet is so you can remove it from the general public, and you can clean underneath your cooker and remove it, and then you can just put it back in. And it should be fine. Okay, so that's why these are self-closing. So for the general public, you are allowed to disconnect this here because this is self-closing. Put the paste into the thread. And just wipe the excess in there. Also helps get it off your finger. Now I've inspected the hose and it's in good condition. It's passed the tightness test. It didn't drop one little bit, so we know it's okay to still use. Obviously if we did a visual and it wasn't okay, then we would have to change it. And again, just tie it up till it's tight and wipe off the excess. Now, one thing you should never use on gas is Boss White. You need to use the right stuff. Now, I've got 5 different types of cooker hoses here to show you. Now, there are 2 main types for the bayonet. So we've got 2 different types of bayonet. We've got the angled bayonet, we've got the straight bayonet. They are both manufactured to 15069 and they are both for LPG and natural gas. So the O-rings inside there for sealing are for LPG and natural gas. So they are the 2 different types of bayonet we've got. This one's for the micropoint and this one's for the larger hose. You see that one's angled and that one's straight. But on the pipes themselves we have what's called the straight connector and we have the angled connector. Okay, so on the straight connector the hose must always be looking down. That would be in your backplate elbow. You would push up and twist and it locks in. Then you push it up, twist to unlock it. Okay, now these are self-closing. So there's no, this is an isolation valve basically, and in our regulations this is not classed as an open end now like it used to be. But if you do think it's going to be left for a long period of time, then you should disconnect this. Shouldn't leave it open. And you can test it by spraying leak detection fluid up there to see whether it's passing. So that is just a straightforward push in. But like I say, the hose must always look down. Now on the angled type, the micropoint, this will be sticking out the wall and this is angled, so this again pushes in and twists and locks in. Okay, and again the hose will need to lock down, comes out that way. Again, self-closing. Again, if you think it's going to be left for a long period of time, it says in the regulations, then it should be removed and plugged off. So let's have a look at these different hoses. Now, the first hose we've got here is one which covers all family gases. So it covers 1, 2 and 3 family gases. If you don't know what the family gases are, gas family 1 is man-made or coal gas, gas family 2 is natural gas, and gas family 3 is LPG. Now this is made of stainless steel inside here with a plastic coating which is to wipe dry and to stop it corroding. So there is a plastic coating over the rubber to stop that corroding. Again, the hose should not touch the floor, because if it touches the floor then the fat and grease can corrode it. So that's the first type. So this covers all family gases. Now the one we've got here with this red band down it. This is for LPG. Okay, now technically you could use this on natural gas as well, but you cannot use a natural gas on LPG, okay, because of the pressures. A good giveaway when you're tightness testing an LPG system with a natural gas cooker hose in, you'll find it goes up and down your readings because it's expanding and contracting. So LPG only with the red band in it. And then we've got this type, and this is made by Tesla. Tesla UK, the cooker manufacturer of hoses, they're not the car manufacturer. And they have this special plastic connector. Now for training, I'm not a big lover of this plastic connector because the ones we've had here, the trainees end up snapping them off because they're made of plastic. But what the plastic is supposed to do is, if there's a fire, this will melt, fall away from the connector and will seal off the gas. So it's a safety device. Clips in and clips out very easily, but we've found every one of these I've got here have snapped off on the inside through to heavy-handed trainees. And then the last one we've got, this is a cooker hose for commercial catering, and this covers LPG, natural gas. It does all three family gases, and this time the bayonet comes out that way, and again it's a self-closing bayonet, but because this is a commercial situation there would need to be an isolation valve as well. So that is your cooker hose for all commercial catering, whether it's LPG or natural gas. So that's a look at the cooker hoses and the different types. So make sure again you pick the right cooker hose for the right application. Now I just noticed there's no plug on it, so we're going to have to nick the plug off the other one before we can plug it back in. Which appliance do you get nowadays without a plug on? So only other thing we've got to do is put the security chain on, and it says you can either use the flimsy little bracket this end, or you can connect it on to here onto the gas supply. That's the only places it tells you can put it on. So you get a hook because that is secure and firm and it's going nowhere. So if they do try and tilt the cooker, then this will stop it tilting forward. Okay, so if you come to fit a cooker, you have to fit a stability chain or bracket. If you go to a cooker to do a landlord report or a service and the cooker is stable, okay, it's not rocking, it's stable, but there isn't a chain, then that's only not to current standards. But if it isn't stable, then it's at risk. Just fit them. So that's the tightness test. It's as tight as it was before. So next thing we've got to do is purge, and we've got a gas rate. Now if you want to know how to do purge volumes and how to gas rate, then we've got 2 videos already showing that, so check them out. Now don't forget, once you've finished with your test equipment, put your test nipple back in, nip it up, and don't forget to spray it with LDF. Leave it for a few seconds and then wipe off the excess. So I've managed to get the cupboard sorted now and get the cupboard back in. So it's in. All I'm going to do now is put the plug on, commission it, and fill in the paperwork. Now, according to the manufacturers, off the top of there to there, we need more than 750. We've actually got 830, but this is an extractor, not a cupboard. And it also says from the cupboard to there we need more than 420, and we've got 485. So we're in with all the measurements from that. No signs of scorching from the old one, so it's in. The other thing as well, where's my level? The cooker needs to be level, but also it needs to be level with the top of the worktop. And it says if it's not level with the top of the worktop, then the cupboards have to be 100mm away from the top of there. But we've got a metal plate on the edge there, so it's non-combustible. And this is just slightly higher than the worktop. So that allows us to have the distance. We've got the distances down the side, so happy days, it's in. So I've just purged, got rid of all of the gas. I've now got the 3 biggest rings on, so I'm going to do my working pressure at the meter, and then I can individually gas rate everything and make sure everything corresponds with the manufacturer's instructions. And with the 3 biggest rings, that is our working pressure at the meter. Now we're allowed a 1 millibar difference between that and our working pressure at the appliance, and there is no given test point on this, so we would have to do that at the injector following a risk assessment. Well, first thing we're going to look at is if a cooker has a glass lid and what safety device we're looking for to protect this glass lid. Now, the glass lid is basically a decorative part of the cooker, okay, but as the name says, it's made of glass. So the glass is not shatterproof, okay, so the heat from the rings could actually shatter the glass. If the glass is missing or the glass is broken when you go to service a gas cooker and the safety device has not been made inoperative, then the appliance needs to be notified to have the lid replaced. But if the customer is using something to keep the safety device open to allow the gas through to the hobs, then that would be classed as ID in the unsafe situations procedure IGMG 11. So the way we test it is pick the smallest ring at the front and turn it on. So this is my smallest ring at the front. Now, I don't know whether this glass lid works or not, so what I always do is just turn it down a little bit. Don't want it on full burn because I don't know whether this works. And then I'm going to slowly lower. Okay, we can see it's gone off. Okay, so what I can do now is I can turn it on fully, knowing now when I shut the gas lid it shuts off and I can see it's gone out. Okay, now what I can do is I need to test all of them, and now dropping the lid down and we can see all 4 go out. Turn it back on and I can see they're all back on, they're all working and everything's tickety-boo. Next one we're going to look at while we're here, it's a control, not a safety device, it's a control, is the gas tap. So basically we turn it on, okay, and it's giving us a good flame picture. We now turn it to minimum, make sure it doesn't go out, and we can see now that that hasn't gone out. We can now turn it back up and turn it off. Okay, so that's just something as simple as checking whether the gas tap's stiff or not working, not turning off. The next safety device I'm going to look at is the thermoelectric device. Now the oven we just looked at doesn't have any thermocouples on the hob itself, sorry. So the thermoelectric is made up basically of 2 parts. We've got the thermocouple, which has 2 dissimilar metals with heat put together onto those 2 dissimilar metals will make about 14 millivolts of electricity, which Thomas Seebeck found out. What that does is it opens an electron magnet. So the part of the safety device we're checking is the thermocouple lights and stays lit, and that's creating that electric to actually keep the thermoelectric open. So I've got to hold the knob down to override the safety control. So I'm overriding the thermoelectric part, the electron magnet. Now the thermocouple's heated up by the gas. It's now made that 14, 18 millivolts of electricity, which is now keeping the magnet open. Now when I blow this out, it has a time to knock off that that electron magnet. On the old cookers, on the whole top, it was 90 seconds. It's now 60 seconds for all, unless the manufacturer tells you anything different. Normally what you would do is turn it down to minimum and blow it out. I'm going to blow it out at maximum so you can kind of hear the gas coming out. So you can hear that gas coming out. I would now start my stopwatch. And that knocked off in just under 10 seconds. Okay, now I can't hear any gas coming out of there, and if I press the button down and light it, I can see it's not passing. That is completely shutting off because I can't hear any gas coming out, can't smell any gas coming out, and the igniter's not igniting anything. So we can pretty much say that's correct and works. So we'd have to do that now for all the others. So I've tested all those. We can see there's no gas coming out, I can hear there's no gas coming out, I can smell there's no gas coming out. So we can say the thermoelectric devices on this hob are working. The electron magnet is also working and sealing off. So everything's tickety-boo. Now the next thing we're going to look at is the actual oven burner in a cooker. Now there are two types of burners, well not burners but the flame supervision devices. There is one which is called a liquid expansion or liquid vapor valve, and one which is worked off the thermoelectrics. So the first one we're going to be looking at is the liquid vapor valve. So let's have a look now. Now this cooker has the liquid expansion or the mercury vapor valve in there. So the older, really old ones had mercury in, the newer, older ones had alcohol in them. So to light the oven, what we need to do is we need to press the oven knob in, because we're overriding a safety device, so we've got to press the knob in and then we can light it. So this oven has to light in low rate. If it lights in high rate, that means the liquid expansion or the mercury vapor valve is stuck in the open position, and that would automatically make this oven ID because a safety device is not working. Then it goes up to high fire. So I now know that this burner has lit in low rate, it's expanded the file inside there with the alcohol or the mercury in there, which has now opened a set of bellows and the gas valve and allowed the gas to go in full burn. Now when we press the button in, we allowed gas through what's called the bypass rate. Now the bypass is actually kind of the pilot light. When we press the button in, the gas goes down the pilot, that's what lights, then that heats up the file, which then opens the main gas valve, which allows the gas in. Now I'm going to test and see whether the bypass is still working, and I'm also going to test the actual mechanical thermostat in this oven is working correctly as well. So I'm going to close the door and I'm going to turn the main oven onto slow cook or simmer. And what's going to happen now is the thermostat inside the oven is going to now work, and that's also a file which also has alcohol in there, which also affects the valve. So it will expand and it will close the gas off to the valve. So it will reduce it back down, should do, to the bypass rate. Now, if it goes out, when it goes down in temperature and shuts off the main burner, that means the bypass is blocked. If it doesn't go down at all, then that tells us the mechanical thermostat's broken. So we're kind of doing 3 tests in a very short space of time on this oven burner. And it now sounds like it's gone off. Okay, so it should, when we open this door, still be lit, but in a very, very low flame. And it is. So that means the liquid vapor valve's working, the bypass is working, thermostat has taken it down to the bypass rate. I'm just now waiting for it to go back up to full fire again because all the heat's coming out of the oven. And again, that tells me the mechanical thermostat is working correctly. The last check I'm going to do now is I'm going to, now it's in low rate, the burner, I'm going to blow the flame out, and what should happen now is the liquid vapour should cool back into a liquid and then knock off the main gas valve. So we should hear the gas valve try to go into high rate because it'll think the temperature's changed. It will then realise via the vapour part of it that the heat is gone there now, and it should knock off the main burner. But the only problem with these is it still leaves the bypass leaking gas out. So it's on low rate. Should hear the gas come up. It's now knocked off and it's lit in the bypass rate. It's now gone back up to full burn. So that's the final check for this. Now, the flame supervision device in this oven burner is thermoelectric rather than liquid vapor. So the tests for that are pretty much the same. So I'm going to turn it all the way on to maximum. I'm pressing the button in now and you can hear the gas coming out. But this time, the oven lights in high rate rather than low rate. Now, what I'm going to do now is, I'm going to turn it down to simmer again so you can see it's in high rate. I need to close the door. So as a gas engineer, one of the first things you need to do really is find out, before you start working on the oven itself, is it a liquid vapour? Is it an old liquid vapour? Or is it one of the new thermoelectric ones? Even when a gas engineer is taking his reassessment, or it's a new guy taking his initial assessment, my advice would always be, before you start working on that cooker, when you're doing your visuals, have a look and see what safety device it does have. Okay, it's nearly gone all the way down now, so I know the mechanical thermostat is working. So what I'm going to do now is I'm going to blow it out. Hopefully we're going to hear this click, and this click has to be within 60 seconds. Once the click has happened, I'm going to try and light it. It shouldn't light because the thermoelectric should knock it off completely. There you go, you heard the click. So if I try and light it now, it shouldn't light, and it isn't doing. So I know the thermoelectric has knocked off, but we got pretty close. I don't know exactly how long, I think it was about 30-35 seconds. So we were still well in with the 60 seconds. So that's how you test the thermoelectric device on the oven burner. Next, we're going to have a look at the safety devices on grills. Again, two types of grills. This is the high level grill, and then we've got the low level grills. So let's have a look at the high level grill first. Now this grill has a thermoelectric device in it. So again, I've got to press the knob in, press the igniter to light it, leave it for a few seconds, let my finger out, and now it's controlled by the gas tap on the front, so I can have it on high, or I can have it on low. Okay, there's no temperature control on this, it's just basically more gas or less gas. But it is, the safety device on this one is actually the thermoelectric device. This high level grill only has ignition. It doesn't have any kind of safety devices whatsoever, but still you control it on high and low by the use of the gas tap on the front. There are no thermostats in this at all. This low level grill is slightly different. The burner is slightly different, but again there's only ignition down this end. There is no safety devices. Now, this is one of the things I keep encountering on my little trips out with the trainees when we do portfolio stuff. Silver foil on top of the cooker. It's a massive no-no. And I'll explain why it's a massive no-no. First of all, let me just remove this here. This here is where the air comes in for combustion. So we've got pre-air comes in here, and then this post-air keeps it stable here. So 50% of the air required for combustion is going down there. we just covered that. That's one thing. Also, have you noticed that the actual ports are higher than the base of the hob? And that's because if anything spills over, it's got somewhere to go. The only place if something spills over here where that's going to go is inside where the injector is. So you're going to end up filling the injector with water rather than protecting it. And the other thing is, if you've got automatic ignition and you press the button and you've got silver here, it makes this live as well. So it can pop when it's going. So don't cover your cooker in silver foil. You might think it's a great idea because it stops you cleaning it, but it's not a great idea and it should not be done at all. So you've been warned. Now, this is also one of the worrying things we see a lot on site when we go and do our portfolio visits with the trainees, is the incorrect use of the ring to the size of the pan you're using. So let me try and explain. So this is quite a big pan and I've just put some water in here so we don't do any damage. And this is the smallest ring on the actual cooker. So if you just move that one out of the way so you can see it. So if I light this smallest ring and I place the pan over the top, now there's a couple of issues we've got here. First of all, you can't see whether it's gone out or not unless you get right up close to it there. Okay, so that's the first thing. So it could have gone out and you couldn't see it. And the next thing is you're actually restricting the air going in to the flame on the post air. So you do not get a stable flame. Now hopefully if I move the pan you'll be able to see the flame being unstable. So can you just see it there? And if I move the pan, you can now see it's a stable flame. So you can see I'm cutting off the oxygen there on the post air, which is kind of starving it of oxygen, and if I move it away you can see the flame then gets the post air and works tickety-boo. So that's why you don't put the big pan over the small ring. So that's the first thing, using a small ring on a large pan, which we see quite a lot. So that's one problem. Let's turn that off, move that out of the way. The next problem we've got is, if I light this ring, so this is the biggest ring on this cooker, and I put the pan over there, and it's actually going over the side. Okay, so that's another, this is the smallest pan I've got. I could have done with a smaller one to explain this, but there you go. And the other thing is leaving the handle sticking out. That's dangerous. You need to look at sticking the handle to the side there. And if you are melting and scorching your pan handles, that's a good indication that you've got it on the wrong size ring. So you don't have the actual gas lipping around the side. That shows you're on too big a ring, and if you can't see the ring, you can't see the gas burning, then you're on too small a ring. So make sure you choose the right size ring for the right size pan. It's not rocket science, guys. Next thing I want to look at is the actual seal in the oven. Now this oven has got a seal, but at the top here there's a gap. That's important. Okay, that's a manufacturer's gap. So not all cookers have the seal going all the way around, because it needs to get air in for combustion. So the manufacturer has certain seals, different types. Some of them do go all the way around, some of them have the seal missing at the bottom. But you need to check the seal and make sure it's working. So the easiest way of doing that is get a piece of paper, shut the door, and if you can feel resistance, then you know you've got a seal. Now obviously we've got to watch the lock in the door. So you can see that side's got resistance, that's got resistance, and you even need to check this side. So you can feel there's resistance, and it's important that you check that because the heat could be escaping out through the sides, and we don't want that. The heat needs to come up through technically it's the flue at the back. We'll have a look at that later. There are also safety devices in the oven, and there's two different types of safety devices. There's a liquid vapor and there's a thermoelectric. Now, without going into too much detail, if you're not a gas engineer, that all depends on how the actual cooker fires up. If it's a liquid vapor, it will light in low rate first before it goes to high rate. But if it's a thermoelectric, it will light in full rate. I've done a full video on the safety controls for cookers, so if you are a gas engineer, then you can go over and check, or a trainee gas engineer, you can go over and check those videos to see exactly how they work. Now, this is the most important part. Now, if you have read the reports on these tragic deaths of these people, and my condolences go out to the families of these people. It's something that should never happen in this day and age, but obviously accidents do. So yeah, but it's the grills, okay? Now, this cooker, or this oven, is exactly the same as the one we've just been looking at, the one with the silver foil on the top. But this one still has its safety devices working correctly, and it's a fully working grill. Now, first thing is, I don't know of any cookers out there or ovens out there where if it has a grill built in, this has actually got a top oven and a grill, so that you can use them with the door closed. I don't know of any. There may be some out there which I've never seen, but the door should always be open when you're using the grill. Now, if we open this, there is a seal around here, okay? And that seal is for the top oven, not the grill, because the grill door needs to be open. Now, you can also see there's a piece of glass here, and this piece of glass is important because if you have a glass door on the outside and that glass is missing, then it's dangerous because a little kid could stick to it. Never mind a little kid, an adult could stick to it as well, because that glass could get that hot. If they touched it, they would get burnt. So that glass is important. So if that glass is missing, your cooker's dangerous. Now, if I turn this cooker on and open the door, you can hear it's fan assisted. And it's fan assisted on the actual oven, top oven, and the grill. So there's a little lever here which activates the fan, but what it also does is it turns off the grill. Now, if I turn this grill on and light it, it's lit, and I close the door slowly, you will see that the actual grill went out and the fan went off. So the safety devices are fully working on this top grill, because if I close the door by accident on the grill, it will knock off. Okay? And when I open it back up, it starts, but there'll be gas still coming out of there. I've turned it off and I'd have to relight it. It's also important, guys, that your ignition works. Now, technically, is your ignition not working dangerous to the gas regs? No, because you could use something to light that. But, in my opinion, if your ignition isn't working on a cooker, you need to get it fixed. okay, or buy a new cooker, because it can be dangerous when your ignition is not working. Okay, so this is a fully working grill, how it should be, and how you test and make sure that it's still working. Let's go and have a look at the one next door and see why that one is here and why this one is incredibly dangerous. So, virtually got exactly the same cooker here. Listen. So it's got the same fan, operating the top oven, operating the grill. But what can you see missing here? The glass is missing. Now when we actually got this cooker, this glass had a massive crack right the way through the middle of it. It was in two halves, so it had to go. So remember, this is a training centre, so the guys have to be able to spot that this glass is missing for the reason I've just explained. Now if I light this grill, and it's now lit, and I slowly close the door this time, you can hear the fan goes off, but the burner stays on. So the safety device is not working on this grill. So this grill could potentially kill somebody, because with the door closed, if this glass was here, it would seal against this seal here and create deadly carbon monoxide. So you need to check your safety devices, and you need to read the manufacturer's instructions for your appliances, so you know exactly what you need to test and what your cooker actually has with it. So never ever throw your manufacturer's instructions away for any gas appliance, whether it's a cooker, fire or a boiler. Keep them safe, because the engineers need to see that information, because not every gas appliance, whether it's a cooker, fire or boiler, are exactly the same. Now, I've finished the cooker, but according to IGM 11, our unsafe situations procedure, because I've allowed air into the system because I've altered the pipework, I need to do some safety checks on the appliances I've encountered. So I've encountered a boiler, and there's also a fire in the front room. So I'll need to do some checks on that to make sure that it's fluid correctly, it's stable, it's secure, it's not leaking, it's not leaking products of combustion and all that kind of stuff. So I'll need to do those tests to make sure and fill all that in my paperwork. Okay, so don't forget, IGM 11, you must do a risk assessment on your appliances you encounter. So let's get them checks done. So that's Appendix 5 of the Unsafe Situations, IGM 11. So let's finish off by having a look at the ventilation requirements. So first of all, we've got appliance type. So if it's a domestic oven, hot plate, grill, or any combination thereof. So it doesn't matter what you've got. Also it doesn't matter what the maximum rated input is. You will still have to go off this section here, which is all about the room volume and the size of the permanent ventilation required. So if we have a room volume of less than 5 meters cubed, we'll need 100 centimeters squared of free air plus an openable window, or any other way of extraction. Now this opening window has to go direct to outside. If you've got a conservatory built onto the back of your house, then that can cause a few problems and it gets quite technical. So basically, if you are having a conservatory built on the back of your house and it's covering your kitchen window, make sure they leave the window open so it can go to outside. So this opening window has to communicate direct to outside air. If we have a room volume between 5 meters cubed and 10 meters cubed, we need 50 centimeters squared. We've got this little asterisk, we'll have a look at that in a minute, and we also need an openable window. And if our room is greater than 10 meters cubed, we don't need any permanent ventilation, but we still need the openable window. Now, if we've got a room volume of between 5 and 10 metres cubed, if the room has a door opening direct to outside, the no permanent vent is required, but the opening window still is, or any kind of extraction which complies to the building regs. Now, if you have a bedsit, your bedsit has to be over 20 metres cubed before you can have a cooker in it. Other than that, you can have a single ring or hot plate. You can't have a cooker if your bedsit is less than 20 metres cubed. Okay, so that's the ventilation requirements for these cookers. If you don't have these ventilation requirements, then you can't have a cooker installed. Well, a gas one, you'd have to have an electric one. So that's really important, what all the gas engineers should be looking for when they're coming to service or commission or install any kind of cooker. Range cookers are slightly different, and you should always refer to the manufacturer's instructions for range cookers and follow those for your ventilation requirements. So that's vents. And that is the end of this video on cookers. So if you've liked this video, why don't you give me that thumbs up or leave a constructive comment down below. If you've not subscribed to my channel, then please subscribe because it helps. And don't forget to hit that notification bell because you want YouTube to tell you when we're uploading videos. Hopefully you know by now it's Mondays and Wednesdays. All I've got left to say is, thanks for listening, thanks for watching, and I'll catch you on the next one, guys. Cheers.